I want to start off this video by introducing or reintroducing some simple concepts of algebra. And I always start this by saying, look, hang on, I'm having a little trouble with my pen here. Okay, we're back. I always start this by doing some algebra here, and this is my stupid game. So if we have this expression, this is distinctly a part of algebra. Algebra introduces a couple of concepts. One is equality, that the concept that what is over here on the left by this sign exactly equals the quantity over here on the right. The second concept, one of the concepts that algebra introduces, is the notion of a variable. And of course, all a variable means is that it can be anything, or it's also an unknown. So knowing or realizing these two things, I'll ask you a simple question. What is it that you know if we have the statement x equals 3? Well, it sounds kind of stupid, but we know that x as a variable is equal to 3. Now, it is important to understand what we do not know. And that also is what x is not. If x is 3, we know that x is not 2. We know that x is not negative 3. We know actually a far more than what x is, if you really stop and think about it. So how is it that algebra seeks to express that? Well, if x is not 3, then we need some way in algebra to express what x might be. So if it's not 3, there are a couple of possibilities. X, any value of x could be either greater than 3 or less than 3, and we express that this way, where this sign is, greater than, and the opposite one, going the other direction, is less than. We can also add to this by putting a half and equal sign here. So this is greater than or equal to. The other way to express this is going the other way, and this of course is less than or equal to. If you look at the top of page 204 in the text, you'll see a number of properties of inequalities, and these are very much the same, very much similar to the properties of equalities. We can have addition property of inequality, where if we have, and I'll follow along here, if we know that A is greater than B, and we know that C is greater than or equal to D, then we also know that if we add these to the same side, then A plus C is going to be greater than B plus D. Please look at the top of page 204, and follow along with these properties because they are important. And I'm going to assume that you can do that on your own. Now, let's look at theorem 6-1. We have already had some of the terms in this theorem. And one of the terms is, in my silly game here, what do you know? Well, we have a triangle, and if we extend one side of that triangle, we can make an exterior angle, which is right here. And if we make that exterior angle, we know from the previous chapters that the sum of this exterior angle is equal to, the measure of this exterior angle is equal to the sum of the remote interiors. So if we have angle 3 here, then we also know that the measure of angle 3 is equal to the sum measure of angle 1 plus measure angle 2. Okay, but that's an equality. And this chapter is on inequalities, so what we can easily say is that, look, if this angle 3 is equal to the sum of these, then looking at theorem 6.1, we can say that the measure of angle 3, an exterior angle, must be greater than either one. Measure of angle 2, it is also greater than the measure of angle 1. And that's theorem 6.1. There are two things I want to point out in section 6.2. And one of the things, concepts that is important is the notion of if-then statements. And we've talked about if-then statements already during the course of the year. And they are generally written, if, not in, if P, then Q. I didn't pick the letters. No idea why math books like to do that. And this is called a conditional statement. We studied that a couple of chapters ago. So a conditional statement. Now, one of the benefits of geometry is teaching logic. And logic is rhetoric, and rhetoric is developing an argument. And that doesn't mean necessarily, and hopefully it doesn't mean angry. An argument is just developing a case where you try to convince somebody. So if we have this statement, we can vary this in the following ways. We could change this up and say, and reverse these two. We could say if Q, then P. And we could take the negative of both of these. We could say if not P, then not Q. And of course we could take the negative of this one, and we could say if not Q, then not P. And I put this in a little different order than the book does because it makes more sense to me. If this is our original statement here, I like to go in alphabetical order actually, and this is the converse here. And then if we go back and take the two negatives, if we do the negative of the original statement, that's the inverse. If we do the negative of the converse, it's the contrapositive. I'm going to run out of space there. Contrapositive. Okay. Now again, these are summarized nicely on page 208 in the text. So we start out with if P, then Q. I like to go and reverse those. The converse, if Q, then P. That's the converse over here. Then I like to take the two negatives. The negative of the original statement is the inverse, and the negative of the converse is the contrapositive. Now, the second term, or the second concept that is developed here in 6.2 is a notion of Venn diagrams. And Venn diagrams are circles. And you can read through, please, on page 209. It's a lot easier for you to read through this, I believe, in the text. But basically, here's the concept, that Venn diagrams utilize circles, and they basically serve to say, look, if this is the whole piece here, this pink circle, this within the blue circle lies within. But there is area outside here that could be within the pink, but not within the blue. Now, there is only one reason that I do this, because I suspect from my experience that you're going to see Venn diagrams on standardized tests. So please, I have this in the homework. Make sure that you can do these. They're quite simple, but they are pretty important.